In this video, I will show how to work with data that you collected with VrisBox. You can watch previous video on our channel to see how it can be done in a couple of minutes. Assume you already recorded some data, so what you do next? Here is the breath platform. You likely already have access to it. You open patient management. You can create a new project. You choose like research project, temp project. So we create it, and then we go into. We see 0 patients here, obviously, because we didn't add anybody yet. We choose add patient. Here we see different types of file. We can add different files. Now assume we collected data with VrisBox, and we click select on drop file. So you can drag file here, but assume we choose select. This is how, so you will get some kind of archives. This will be folders, so each episode between 2 standby modes will be each folder, and in each folder you will have 2 files. So this is parameters and waveforms file. So this from one of the Hamilton ventilators, so that's called like parameters Hamilton, waveform Hamilton. If you record the data with Drager, then it will be parameters Drager, date, time, and parameters of waves. All these files you can open in Excel, in MATLAB, so any other software, so you are free to use it. But here I want to show how to use the breath to work with this data. So you compress all these files, so you should make a zip archive from these files, and you upload a zip archive with folders, always one folder. It doesn't matter, one folder or 50 folders, everything will be uploaded, and each folder will be considered as a separate patient. We will do it later. So I click at patient, procedure starts. So we see it means that session is created. We start uploading wave files. We uploaded waves. It's 81 breath, and then we upload parameters. So you need to see all files processed successfully. Then we close. We see here patient duration less than 1 hour, start of ventilation, end of ventilation. For example, how we can open. So let's say we archive all this patient here, all folders. We click compress, and we get archive. Again, what does it mean? I can add more, and now I go here, I choose archive, and we expect many files here. So we see that process, so it was patient 66, 67, so it's upload automatically all the files, all the folders that you recorded. So for example, if you were recorded like for 5 days, it will create maybe 3 patients, it will be 3 folders, and you can upload them with one operation. We see we have many patients here, so this one the first, and for example, it was in reality 1 patient, just there was some time standby mode during operation. So we select all of them, we click combine, and we joined all this patient to 1. So now it's only 1 patient. Very fast, very easy, and it's possible to do to split a patient in between. So a lot of things, it's out of the scope of current video. Okay, what we do now? So we uploaded file to patient to deep breath. We go to analytics. We choose patient that we want to review, and now we can review all the episode of ventilation, and this is critical parameters. For example, critical, I mean parameters for which usually alarm settings are set. Here are, for example, already automatically calculated mechanical power and dissipated energy. So this was unreal patient, so it was balloon. So we cannot visualize asynchronous now, but if it was real patient and the patient had asynchronous, so we will be able to visualize them automatically. So for example, here are control settings. So we see that it was ASV mode, then it was pressure control mode. And if we zoom in any moment of time that, for example, that is detected as asynchrony because it's calibration of in Hamilton ventilator, so it detects something unusual, but usually it's not highlighted in any way. And so we see that like any waveform can be zoomed in as very accurately. And here you already can do some analysis. You can export back only necessary parameters that you want to export, clicking here. And you can visualize parameters that you would like. You can save this image. So this chart as an image, it's already saved. So everything happens in just one to click. We can create a report for this ventilation. So we see distribution of mechanical power, minute volume, respiratory rate, report. It appears that 1% of breath was triggered. Alarms, if they would be, and also like asynchrony index. So basically something was considered as a failed trigger even in the balloon, because maybe waveforms looked like, or we tried to simulate them. I don't remember actually. In another tab that's called research, we can visualize distribution of parameters for during the ventilation. So distribution of peak pressure. So currently it's maybe not so interesting because not so many breath, but if you have one, let's say, day of ventilation, so it's more interesting to review this distribution. So let's do it with another patient, for example. So here we can do it. Let's go back and let's open maybe this project. We have longer ventilation here, and here it's a little bit more interesting to review distribution of parameters. So we see that this is basically a little bit more interesting. Peak pressure, tidal volume. We can also zoom in. We can save these images. We have distribution like median, maximum. We can export these parameters, so to Excel, to double check, to use in your research. So it's also just in a few clicks. And let's check what modes of ventilation exist in this patient. So no, it's only ASV, it's not interesting. Let's add another. I want to also check here. Yes, here we have two modes, and I can set here different conditions. So for mode ASV, we want to get distribution of tidal volume, peak pressure, and for example, respiratory rate. And the same will be for volume control mode. We click go, and we get distribution for ASV, for volume control, and we can compare also all these parameters and to see what more safe for patients, for example. Again, we also can compare calculated parameters like mechanical power, amount of asynchronous by type or in total. So that's what is possible.